So welcome to Electronics Excel Lab, and you are watching Signal System lecture series. And today the topic of discussion is the block diagram representation of a discrete time system. Okay. So we have seen what is discrete time signals. Now it is the discrete time system. So anything that is obey on the discrete time signals is not a discrete time system. Okay. So anything it takes the actually discrete time system takes the input signal as a discrete time signals, and it gives the output as a discrete time signal also. So, but some predefined rules it will give the output. The input of discrete time system is called which means excitation. Okay, and the output of discrete time system it will call the response of the that system. So it is actually it takes the discrete time signals, and it will according to some pre-described rules it will give the discrete time signal also. Okay, so it takes the discrete time signals as a input or excitation, and it will give the output as a response or output of the systems. Okay, so let us means in details will describe this discrete time system. So there are many discrete time systems like an adder, then constant multiplier, a signal multiplier, then a unit delay element, and unit advance element. So these are the discrete time systems. So let us take one by one. Okay, so let us begin our discussion. So discrete time system. Okay, so as I have told you, it is a device or algorithm that performs some pre-prescribed operation on a discrete time signals, and it is the discrete time. It is called the discrete time systems. Okay, so a discrete time system is a device or algorithm that operates on the discrete time signal. Okay, that that it is called input or excitation. Okay. Similarly, according to some well-defined rule, it will produce another discrete time signal that is called the output or response of the system. Okay. So it will operate on discrete time signals only. Okay. So the input that is called the input or excitation, and the output of this discrete time system is called the output or response of the systems. Okay. So we have an input signal that is x of n is the discrete time signal, and it is transformed by the system to into another signal that is y of n. So general relationship between the input and output is that y of n equal to transformation of x of n. T is the transformation. Okay, or operated, it is operated on x of n according to some rules. Okay, so that will be, it will give rise to the y of n. Okay, so it will take input or excitation, and according to some means operation it will transform the x of n, and it will give rise to the y of n or response of the systems. Okay. So that symbol T denotes the transformation, or it is also the operator. Okay, or processing performed by the x of n to produce y of n. Okay, so let us see the diagram. So you can see this is our x of n. This is also a discrete time signal. Okay, so the discrete time system, it is a algorithm or device. It will take the input that is also called the excitation. The input signal is a discrete time signal, and so it will operate on the x of n. Then according to some operation, it will give the rise to the y of n. Y of n or response of the system. Y of n is also called the response of the system. Okay. So this is the discrete time systems. Okay. Let us take see that how many discrete time systems are there. Okay. So types of discrete time system. First, we have seen, we will see the block diagram representation of the discrete time system. Okay. So first, we will see the adder. Okay. So what is the adder? You can see. So it is a system that performs the addition of two sequences to form another sequences. The another sequence, it will sum the two sequences. Okay, that is denoted as y of n. Okay, and it is not necessary to store either one of the sequence. Actually, this addition is memoryless. Okay, we are not taking the past values of the input. That is why it is known as a memoryless. Okay, so let us see the diagram. Okay, we can see this is x1 of n, this is x2 of n, and this is the adder. Okay, so it will add this two x1 of n and x2 of n, and it gives rise to y of n, y1 of n. Okay, gives rise to y of n or y of n. Okay, so this is the adder circuit. So this is how you represent an adder circuit. Okay, so this addition operation is memoryless because it does not depend upon the input samples, a past input samples. Okay, that is why it is a memoryless. Okay, this is the an adder circuit. This is the block diagram of an adder. Okay, similarly, and constant multiplier. So you can see the constant multiplier means it is the x of n will be multiplied by a scale factor. Okay, that is the constant multiplier. So x of n will be multiplied by some constant. That constant is known as a scale factor. So this operation also memoryless. Let us see the diagram. So you can see x of n it is multiplied by a is a scale factor. Okay, that y of n equal to a into x of n. Okay, so output equal to multiply, it will x of n multiplied with some constant, that is a is a scale factor. Okay, so this is the how you represent the constant multiplier. Okay, let us see the signal multiplier. Signal multiplier means it will multiply two signals. Okay, suppose there are two signals, that is x1 of n and x2 of n, it will multiply the two signals and gives rise to the y of n. Okay, so it will give rise the product sequence. This operation also memoryless. Okay, so you can see x1 of n and x2 of n both will be multiplied. Okay, so y of n equal to x1 of n into x2 of n. Okay, so this is the block diagram of a signal multiplier. Okay, so let us see our next. So a unit delay element. So unit delay element means it will delay the sample by, means delay the input by one sample. Okay, that is the input element. So if we give the sample x of n, so it will delay by one unit of time. So it will be x of n minus 1. Okay, so let us see that. So the unit delay element, or it is a special system that simply delay the signal passing through it by one sample. It will delay the signal by only one sample. That is why it is unit delay elements. Okay, so let us see how it is represented. So you have x of n is the input signal, the y of n equal to x of n minus 1. Okay, so x of n minus 1 is stored in the memory. Actually it depends upon the past value. That is why this system, okay, is known as a it requires some memory. Okay, so this is how you represent y of n equal to that is the x n of n minus x of n minus 1. Okay, so this is how you represent. It will delay the means signal by 1 unit input. It will delay the input by 1 unit of time. Okay, so let us see how the block diagram requires. So this block diagram is actually represented by this z inverse. Okay, the unit delay element. So you can see this is the block diagram representation of a unit delay element. So it is operator means denoted by the operator z to the power minus 1. Okay, and it will give rise the output as y of n equal to x of n minus 1. Only one unit it will delay. Okay, so this is the unit delay element. Okay, let us see the next one is a unit advance element. Unit advance element means it is the ahead plus one sample that will n plus 1. Okay, so it requires some memory actually. So the output will be x of n plus 1. Okay, so let us see how it is represented. It is represented by the operator z. Okay, so this is the means block diagram of a the unit advance element. So it is operated on x of n. It will give rise to the x of n plus 1. The output will be x of n plus 1. Okay. So actually, it is not possible to physically possible to means advance the element. So that is why it involves looking into the future of the signal. Okay, because x of n plus 1 means you are looking into the future of the signal. Okay, but you can you can, if you store the signal in the memory of the computer, we can recall it at any time. That is the meaning of unit advance element. Okay, so it requires some memory. Okay, so it is also requires some memory. So in run-their system, it is possible to advance the signal in time. Okay, but in practical physics, it is not possible. Okay, so these are the some block diagram representation of discrete time system. So we have seen the multiplier, then adder, then we have a unit delay element and unit advance elements. Okay, so unit delay element is indicated by means it will denote the sequence as z to the power minus 1, and unit advance element it is operated by the symbol z. Okay, or it is represented by a symbol z. Okay, so this is how we represent the discrete time systems. Okay, so thank you all. So thank you for watching this video. Stay connected to this channel. So if you have any doubt, please free to ask me in the comment section. Okay, so thank you all. Have a nice day.